Now that we've completed our step 11.5 notes about plotting points and vertical and horizontal lines, we're now ready to talk about all the other lines. Not every line will be perfectly horizontal or perfectly vertical. Many lines that we encounter will be diagonal. The way we know they have a diagonal slope is because, or a positive or negative slope, they will have both an x and a y. There's many ways that you can graph lines, and trust me, we're not trying to just inundate you with 4 different ways to do the same thing. Some situations, one tool will be easier to use than another. So we're just trying to equip you with lots of tools so that solving and graphing these lines and inequalities will be easy to you. Let's look at the first method. We're going to graph a line given 2 points. Now, this is a really nice scenario when they give you 2 points. All you need to do is plot the points and connect the dots. Connect them. -3 says 3 to the left. +4 says go up 4. The other point is 5, -2. It says go to the right 5, down 2. Plot the point. And then using a straight edge, we're just going to connect these 2 points. It's okay if you miss it the first time. You can kind of drag it into place until you get it just right. There we go. One key feature, you want to make sure that even though the points are from here to here, you don't want your line to stop here. Make it go through the entire coordinate graph. It should go edge to edge all the way through. What's the slope of this line? It is a negative slope. And if we wanted, we could calculate it, but that's a little bit more like step 10 and 11, so we're not going to do that at this moment. Instead, we're going to look at what it would look like to graph given 2 intercepts. Well, if you remember, intercepts are just points. If the x-intercept is -4, that means -4, 0 is the point. We make y 0 for the x-intercept, and for the y-intercept, we make x 0. So now it's just like the first example. We're going to plot 2 points, -4, 0, 0, 7, and connect the dots. Take your time to get your line to go straight through the dots as neatly as possible. If you're using paper and pencil, I encourage you to use a straight edge or a ruler when making your lines. Notice that my line goes all the way through the entire graph, the entire coordinate axis. And I put arrows on the ends because it goes on forever. What if we have a y-intercept and a slope? For instance, they tell me that the y-intercept is 5 and the slope is -2/3. Well, remember from step 11 that the y-intercept was my b value and my slope was my m value when we thought about slope-intercept form. B was the number all by itself, and m was my slope. It was the number right next to x. So you might be given this information all spelled out for you, or you may have been given the equation that looks like this, where you need to know what the y-intercept is and what the slope is. We're going to always, always, always begin with b. Begin with the y-intercept. Now, think about it. Is bx a word? No. So I'm not going to put the b with the x. Is by a word? Yes, that's the word by. So we're going to begin by putting this 5 on the graph. The y-intercept is 5, so I'm going to go up to 5. Now I'm going to move m. So we begin with b and move m. What does negative 2 over 3 mean? Well, we give the negative usually to the top number. So I want to move negative 2 over 3. That means I want to rise down 2 and run to the right 3. So starting where I just put my B, I'm going to go down 2, right 3, down 2, right 3, over and over as many times as I'd like, so that I get a nice line. And again, my line goes all the way through the coordinate axis. It does not just stop where I had plotted some points. A fourth option is to use your calculator. Sometimes they'll give you an equation, and you can just plug it right into your calculator, particularly if it's already in slope-intercept form or y is all by itself. That's key. We need y to be by itself. Let's take a look at what this will look like. So I'm going to first make sure I can see my equation. After I've turned on the calculator, I'm going to press y equals. And the reason I'm doing that is because I am given that y equals something. So if I want to put that in the calculator, I need to start by pressing the y equals button. If you have other things in your calculator, as I do, just go ahead and clear them out. And press clear. So you're starting fresh. Next to the y sub 1, I'm going to type in this fraction, negative 2/3 is typed by pressing alpha y equals 2. Now it got difficult. Let's see if I can get it to go back. There it is. 2/3 x plus, oh, it jumped down on me again, I apologize. 2/3 x plus 5. Sometimes using the calculator on my computer is challenging. Next, I'm going to press graph. And you can see we have a beautiful graphed line. The only problem is it's stuck on our calculator screen and we need to get it over here on the left on our paper or OneNote coordinate grid. And we could take a guess at what that's going to look like, something like that. But that's kind of messy and sloppy, and we want to be a little bit more precise than that. The way we're going to get precise is by looking at a t-table of values and plot the nicest values we can find. So we want to get to this table. Do you see this blue word up here at the top that says table? In order to get there, I need to press the second button first and then graph. And I am immediately taken to a table of values. There's lots of values in this table. The key is finding nice points to plot. Now, what makes a point nice or not? Well, if you look here, -1 is a pretty easy number to find. 17/3 is somewhat challenging though. And while you can plot fractions and decimals on a coordinate grid, it's much nicer to use what we like to call the integer coordinate points, the nice points, like 0, 5. 0, 5 is a very easy point to plot. So I'm going to go over to my graph. And I'm going to plot the point 0, 5, which means go left and right 0, and then up 5. Now I need more than 1 point. 1 point is not enough. So I'm going to go back over to my calculator and scroll down until I get to the next nice point with integer coordinates. 3, 3. Says go to the right 3 and up 3. Now technically that's enough. 2 points is all I need to determine a line. But I'm going to look for just one more to get a nice shape. 6, 1, that's easy to graph. That says go right 6 and up 1. Now, when I go back to my graph here, I'm just going to connect these dots with a line. As neatly as possible. There we go. Now I've graphed the line. Now, if I go back to my graph, you can see what I have on my paper or my OneNote looks just like what I have over here on the calculator screen. All right, let's take a look at a few practice problems. Y equals 4. If you recall from our notes from 11.5, that only has a y, it does not have an x. X can be anything. Can be any number. So I'm going to go where y equals 4, and I'm going to put a horizontal line. Y equals 3x. Well, they didn't give me 2 points. They didn't give me 2 intercepts. But it is in slope-intercept form. Y equals mx plus b. What number is right here that we can't see? It's just a 0. So I'm going to begin with b and move m. I'm going to begin with 0 and move 3. Now we want our slope to always look like rise over run, and right now it just looks like rise. What can I put it over without changing the value? What can I divide 3 by so that it stays 3? 1. So let's try. We're going to begin at 0 and move up 3, right 1. And now I have my line. I could have also typed this into my equation in my calculator and looked at the table of values. And I would have gotten points like 0, 0, 3, 1, -1, -3, and I could plot them and connect the dots. This is another nice one because it's in the form y equals mx plus b. It's very easy to see here what number is by itself. 4. What's not so easy to see is the number before x. It's invisible. When there's no number before x, it's 1. How do we make 1 look more slopey? We put it over 1. So I'm going to begin at 4, and I'm going to go up 1, right 1, rise, then run. And I have my points. I'm careful to make sure my line goes all the way through my graph. I don't want to just connect these two. And I'm finished. This one's a little more interesting because it's not in the form y equals mx plus b. The x and the y are on the same side of the equation. When that happens, it's nice to use intercepts. x minus y equals 3. X minus y equals 3. First, I'm going to make x 0, then I'm going to make y 0. 0 minus y equals 3, which simplifies to negative y equals 3, or y equals negative 3. That's where y equals negative 3. X minus 0 equals 3. That's the same as x equals 3. Since you learned how to graph using intercepts, this one is very suitable to doing graphing by intercepts. You could have graphed with slope-intercept form, but first you would have had to get y isolated, and then you would have to find out what is your b, and then move m. It's a little more involved than just using intercepts. Again, this one we have y, but y is not by itself, equals 10x. Negative 5y equals 10x. Let's just try using the intercepts method like we did before, since it's not in slope-intercept form. Let's see what happens when we do this. All right, first I'm going to make x 0, and on the right I'm going to make y 0. 10 times 0 is 0, equals negative 5y. Dividing by negative 5, I get that y equals 0. On this side, I have 10x equals negative 5 times 0, because y is 0, which is just 0. Then I divide by by positive 10, x equals 0. Oh, and that's a problem, because I need 2 points to determine a line. I don't know if the line looks like this or like this. They have to go through the origin, but I need another point to determine where. So this is an example of why we can't just learn how to do this with intercepts, because here it fails. It doesn't work. We end up with x equals 0, y equals 0. That's not enough information. So instead, I'm going back to the drawing board. 10x equals negative 5y. Let's get y by itself. Let's get it so that we have y all by itself equals mx plus b. In order to get y by itself, I need to divide by negative 5 on both sides. On the right, I'm left just y. And on the left, 10 divided by negative 5 is negative 2x. In other words, if I want to switch this around, y equals negative 2x. Y equals mx plus b. When there's nothing here, you can always put plus 0. So I'm going to begin with 0, and I'm going to move negative 2. And again, to make it rise over run, when there's nothing in the denominator, I can place a 1. So I begin at 0, and I go down to right 1. And I connect my points. Let's try this one using intercepts. 4x equals 2y plus 6. 4x equals 2y plus 6. I'm going to make x 0, then I'm going to make y 0 on the other side. 4 times 0 is just 0. 4x equals 2 times 0, that's just 0, equals 6. I just have to solve these and I will have the intercepts I need. Subtract 6 from both sides. And then finally, divide by 2. Y is -3. So on the y-axis, I'm going to plot a point at -3. Finishing up on the right, I need to divide by 4. X equals 6 over 4, which would reduce to 3 over 2, or 1.5. That's not too bad of a point to plot. Here's 1, here's 2. 1.5 is right in between. And I connect them with a line that goes all the way through my graph. And I'm finished.